Greetings everybody, my name is Yelena. I'm one of the teaching assistants in data analytics program. Today I'm going to cover the neural network classification using R. So here is today's agenda. We're gonna discuss the data pre-processing that you need to do for the neural network method. We're going to talk about splitting data into training and test set, and I'll show you two implementations of neural network, the neural net and also NNet. And for each implementation, we'll discuss the packages that you need, how to run the method, and we're gonna look at the method results. We're gonna look at network visualization. And I'll show you a little bit more than in your exercise Word document. We're gonna discuss the variable importance, and we're gonna talk question and answers, right? I'm gonna answer any questions you may have. All right. So for this presentation, this is a data set that we're going to use. We're going to predict if an individual is a smoker or not. And this is a dataset source, this URL, and the fields are basically the second column. It tells if an individual worked in a building where there is a smoke ban policy. Then we have individual age and so on, right? So basically we have an individual education. This is an individual. It means that if an individual graduated from high school, or if it's a high school dropout, and so on, right? Male, female. And we're gonna use that information to classify an individual as smoker and non-smoker, right? So what is neural network? Basically, if you look at it, here is one picture. This is an example. So you have the first layer is a set of inputs, right? Second layer, somewhere in the middle, is some type of function going on, and then you have an output. So depending on the values of the input, the function in the middle layer gets activated, and based on what it returns, we have the output, right? This is one output node. So I'm going to start sharing my screen. So this is Okay, so I introduced the data that we'll use. Now I'm going to share the screen. And what I did was I wrote a couple scripts for you. So after this presentation, I'll send these two files to your instructor. First, we're going to look at the neural net implementation. And this implementation relies on a backpropagation algorithm. You need to install the neural net package if you have not already. If you have, then you skip this command. After you install the package, you still need to load the memory, otherwise it's not available. And then that's another package, neural network tools. And we're gonna use that for the network visualization. There are several ways to visualize the network. And I'm going to show you how to use this package. And in addition to visualization, you use this package to identify which variables are important, variable importance. And similarly, you have to load this package in memory for it to be available. Since I already installed both packages, I'm only running the command now to load them in memory. Right? So now it's running this command, and then I have to run this one too, library command. Right? Oh, okay, here we go. So I ran the command, and right now what I just did, I just loaded the packages in the memory, nothing else. So what we will do right now is we're going to read the file into the data frame. To do that, we first have to set the working directory, right? And I have a folder on my external hard drive. I called it datasets. Now I'm going to read the data. That's called the smoking. The data frame name is going to be smoking. And that's a CSV file. The first row contains the column headings, and the file is comma delimited. So I'm reading that in. And always, after you read the file, I would recommend running a head command to preview. but the file is about 10,000 line of code, so we need to allow it a bit of time to load, and then we're gonna run a head command to display the first 10 records, right? So while it's still loading, let's look at the slides, and I have another copy of the slides here. So basically, now we're going to talk about the data pre-processing that we're going to need to do. Important. If your data set has a unique identifier, you really have to remove it. Remove unique identifier column before running neural network because it does not really help with the classification, and in addition, it affects the performance of the neural network method. Right? So let's see. Okay, here we go. Now what we need to do is, oops. Oh, I see what's going on. It's because I have RStudio opened. I have RStudio opened twice. That's the problem. So now I'm going to close it. Okay. You always want to have only one window of RStudio open at the same time. Otherwise, you might be running into issues that I'm just running into now. All right. So just remember, have only one window open. All right. So now, not a problem. I'm going to rerun this command, and the command is to load. Right. So I did that, and now I'm going to load this run. Now it's gonna be fast. It's because I had two windows open. That's why. Now I'm going to run the head command, and the head command, that's a nice way to preview, because you want to verify that the data was loaded as expected, and these are my first 6 rows. So by looking at my data, I can tell I don't have a unique identifier to deal with. Most of my variables have values 0 or 1, right? Now, except for age variable. Age variable is numeric, continuous numeric variable, right? So what we have to do is we'll have to handle it, and I'll show you how to handle it in a few. But before we do that, one more step. We need to check if our data set has any missing values, right? This data set does not, but we just still have to check just to validate. There are no missing values, right? This command, it checks if there are any missing values. There are none. Next step, we have to handle the age variable. It's because the variable has a totally different scale. We don't want the large scale to have an impact on results. So the way we address it is we have to scale it. We need to normalize the age variable. I'm not doing it to other variables because basically they're not continuous. They have values 0 or 1. So that's basically discrete, right? They're defined as numeric, but their values are 0 or 1. They're not continuous numbers. But for the age, I have to scale it in this case. Right? So next step, I need to divide my data into the training and test set, because I don't want to overfeed my model to the training data. I need to use 70% of my data to build the model, and 30% of data to validate the model, right? But first thing, I need to set seed. It's because when I run my method again, I want my results to be reproducible, right? So set seed is kind of like set the random number. I'm gonna run this, and I put 1, 2, 3, 4, but you can put a different number. That's what I just put as my preference. And now here I run this command to split data into training and test set. And if you notice in here in the environment, you got this added. You got this added to your environmental variable, and you can see that you have about 10,000 observations total, and this is a number of rows in the test data, number of rows in the training data. Now what you're going to do is you're going to run the method, and I summarized for you the input parameters that the method takes. The first piece here is a formula. Some bad news are that this method does not take the wildcard character dot. So, as you may remember when we did the decision tree, here you would specify the dependent variable, and after this tilde, you would put a dot if you wanted to use the rest of the variables for your predictors. But unfortunately, this method does not support it. You have to physically spell it out. Right? Now, here, I specified the data set I'm going to use. In my case, it's a training data. And then here, I'm specifying the number of the hidden nodes. In this case, I want to have 1 layer and 8 nodes in a hidden layer. Well, usually you want to have less nodes than the number of input, but it's a matter of playing around. And then threshold, default is 0.01, but, well, this input parameter determines when the method stops running, but the problem I had when I tested the data is that it did not converge. So if you get an error, if you get a message that the method did not converge, you want to increase the threshold, because the threshold determines the number of steps that your network needs to run. If the thresholds go up, your results might not be as accurate, but the network will converge. So you have to kind of find the right value. And it was a trial and error for me a little bit. So now let's do this. Let's run this command. Right? Oh, okay, I see. It's because I need to run again to load the package in memory. If you get this error, that means that your package might not be in memory. I had 2 windows open, remember? So now I have to have these 2 packages in memory, right? And let me just, well, just actually that ran, right? Because I was able to run a head command. I was good up to here, right? So now let's run this here again. So it's running, but if it happened not to converge, then I'm gonna bump up the threshold parameter. But I was able to run it with 0.2 when I tested. But again, it's a numerous factors going on. And then, as you may remember, we use the names command to list the variable names in the data set. But here, it's different because, well, we store the output in a variable, and the data type of the output is a list. And names command will return the section names of the list, right? The list contains the sections, and it will return which sections are. And each section happens to be the property of a network. And to see the value of specific property, you put the variable name, which is NN, this is where we store our result. You put a $, and the $sign will follow the property, right? So it's taken a little while to run. If you get an error that it converges, if you get a message that it does not converge, rather, then we're gonna bump up the threshold parameter. Okay, it's finished. We are good in this case. So another reason is that look at how many observations I have. I picked a big data set. So now let's run the names command. That's gonna tell me different portions of the output that I may look at. The call command is gonna give us the input parameters. Well, that's basically what we did to obtain the model. This is the command we ran. This one is going to return our dependent and independent variables. Right? So we are predicting if a person is a smoker, and here are the variables that we use as the predictors. Wait. So remember the neural network structure. Well, it might be helpful to look at these 2 in a parallel. So this is what it's going to look like. And every connection between neurons has a weight associated with it, right? So here are my inputs. I have input nodes. I have a hidden layer, and hidden layer is connected to the output, and it's interconnected. Every input node is connected to all nodes in the middle layer. Every node in the middle layer is connected to the output node, right? So every connecting line has a weight. So the weights command will tell us what the weights are, right? It might be a little difficult to read when you first look at, but it will make sense when you look at this numbering, because every vertex has a number, right? So that's basically how you would need to look at the vertex number in this diagram, right? You would have to look at the, well, it's not explicitly labeled, but it just tells you the weight on the edge. It's the weight on the edge, right? Here, see these lines? And what about these two blue lines? This is called the bias or intercept. This is some bias that gets introduced at each layer of the network, right? But this is a little bit easier to read, the results matrix, where it tells you this is much easier to follow. Over here, it tells you the arrow, the threshold reached, a number of training steps. This is called the intercept, so that's that thing in blue that we saw. It might be easier when you read this. It might be easier to look at this plot and at this output at the same time, right? So let me do the plot here. Okay, so this is easier to look at the plot and to look at this output at the same time. So let's take a look here. Here, this is showing me my nodes and my intercept, right? So this is this is an intercept. And then over here, see this smoker, and to the first, this showing me the connecting line from the smoke ban, right? Smoke ban to the first hidden layer node. So on this line over here, I have minus 1.25. So this is the weight in this line, right? This is how you read it. Then you look at the edge, and this is the line between edge and the first hidden layer node. And then the same thing, high school dropout, you have this line between high school dropout and a hidden layer, and etc. So you have weight on every single line. So basically what happens in the end, it's a combination of weight and some kind of function that gets activated inside the node. Based on that function, it determines which hidden layer node gets active, and then which output gets active, right? So perhaps smoker is a positive class, right? And non-smoker could be the negative class, 0. Non-smoker or smoker 1. So based on what's happening here, we're gonna know if individual is a smoker or not. So if the weight is positive, it means that it's a positive effect on the outcome. And here, this is a negative effect. So in other words, the person is less likely to be a smoker. So let's go up in here. So this is how you read the matrix. And this piece stores the independent variables. This is called the covariate. Those are the values of independent variables from training data. But the reason I want to put head, because I don't want to look at 10,000 records. I only want to look at the first 6. And in fact, you won't be able to see the 10,000 because there is a limit on how many rows you can output to the screen. Now take a look at this. This is age. The variable is scaled. Remember, we scaled it. So that's why you see positive and negative numbers. The next step would be to visualize our network. And we're going to do it in 2 ways. The first way is going to be just the plot. This is what I did here. This is just the plot. Nothing fancy about it, right? So you see different color codes. The black lines is just the lines between the input node and hidden layer node, right? And between hidden layer and the output node. And the blue ones, this is the bias, right? So right now we're gonna do something different. We're going to use the PlotNet function, and in fact, this is what was the function that was used to build the graphic in a course content. In this modular course content, the graphic was built with R, and the PlotNet function is in this one, network net tools. This is a library, and basically, what's the difference is a different appearance here. Let me see what happens. Let me show you what happens. You just got nicely looking vertices. By default, it does not show the weights, but there are also a lot of input parameters that you may play with. And you can do zoom in just to see it better. It just looks different. Take a look at this. Now you have the nodes labeled, right? I1 means that stands for the input nodes. I1, I2, I3, and so on. This is input. H stands for hidden, and B stands for the bias that gets introduced, right? Now what you can do is, this is an example here. You can change the color of the vertex to yellow, right? Or you could also, if you wanted to, you could change the sizes and so on. But to see what you can do, you can see the help page, PlotNet. This will show the help page for this function, and basically you can change the colors of the vertex. You can change the size of the vertex, and so on, right? You can play around with that. Now we're going to look at the variable relative importance, and there are two ways to look at it. And one thing to keep in mind is that when you look at the Garson, your network can have only one hidden layer and only single output. The network has single output when the variable that you're predicting has only two values, like in this case, right? The smoker or non-smoker. But if you had a categorical variable with three values, you would have had two outputs, right? But here, in this case, you have one output, and if you're using only a single hidden layer, then you will be able to use Garson function to determine which variable is significant, and this function is located in this neural network tools package. So this is something for you to look at for your assignment, not an exercise, but assignment. Here it is. So basically what it does is it analyzes the weights, it analyzes the network weights to determine the importance of each variable, and it scales. So the sum of this should add up to 1. And as you notice that the most significant impact on the result has a variable that indicates if a person is Hispanic, and the least significant one is in the smoking ban. Oh, let me see the question. So this is compared, well, yes, it's looking at the weight, that's right. It's looking at the weights from the input nodes to the hidden layer nodes, and it's looking at the bias, and it's also looking at the weights coming from the hidden layer nodes to the output nodes. So I hope I explained it, but what I also did was I wrote it down in a slide. I put a nice summary for you here. I explained it to you, sure, yes. Here. So it's using the weights to determine the importance, and then it's going to scale it. So this is how we do it. But this approach, well, you can use it for neural net or for a net model. And here, for this specific method, you want to keep in mind that your network can have only a single layer, just if you want to use this method to determine the importance. And your categorical output variable cannot have more than 2 values. For this one, your network may have more than one. Your network can have more than one hidden layer, and you may have the categorical variable with more than one class, with more than 2 classes rather. Sorry. Okay, so this will look a little bit different. And take a look. If this is negative, it means that the variable sort of like has a canceling effect. So it means that the Hispanic people are less likely to smoke, and the people who graduated from high school, for some reason, they are more likely to smoke. And people who have people who have some college, right? They have this variable rather, right? If it's 1, it has a higher influence. People are more likely to be the smoker, and this is called the canceling effect, right? It's more negative. And same thing here, college graduate. If you graduated from college, you're less likely, and so on. But this one, the gender and age, they don't have that significant effect. That's what it basically means here, right? Now what we're gonna do is we're gonna check how good is our model. The compute function, we use the compute function to predict, to run the prediction, and we have to take the net result part of it, right? But actually, what's going to be returned is the number between 0 and 1, so we have to round it. We have to round the number. So let's do that, and let's actually run the head command to see the first 3, my predict, right? You want to see the first 6 values. See, this is what it's going to look like. This is a probability, so we have to round it, right? Now we're going to do the confusion matrix. A confusion matrix is a table that shows accounts predicted versus actual. So I have to take the this is the predicted value, and the smoker in the train said this is my actual value, and this input parameter puts the labels so that I know that every row is a predicted, every column is the actual, right? And then I wanted to see the classification accuracy. So basically, the numbers on the diagonal tell where the predicted class equals actual class. So that's how we get. This is a classification accuracy for the training data, right? Now we are going to evaluate the model on the test data. We are taking this is column 2 through 10 are going to be the input for the test data, and then we are taking the results and we have to round it, right? But here, what I'm doing, this is a little mistake. You want to put the head, right? You want to use the head command, because, and the reason is you don't want to okay. What's happening is that you don't want to here, what you don't want to happen is you don't want to display about 1,000 rows, right? You don't want to display thousands of rows. That's the reason. So now what I'm gonna do is you're gonna check the accuracy for the test. You're going to check the accuracy for the test data, right? So let me rerun this again, okay, to make sure that it runs. So this is a classification accuracy for the test data, right? So basically you want to compare. If this is only 1% apart, we're fine. On the other hand, if we had 90% for the training set and 75% for the test data, it means that something is wrong. We might be overfitting the model, right? And this is another option to do confusion matrix. You can do the caret package, right? Require caret. And then here, you get more information, such as true positive, true negative, and so on. So for your assignment, this is a very good area to explore, because for the assignment, you need to go a little bit beyond the exercise, right? And what I did is, after this class, you're gonna have a copy of the slide. Yeah, it's in here, this slide. I put an example on how to interpret these numbers, right? The sensitivity, the accuracy, and so on. So you want to look at that. It's not for the exercise, but it's for the assignment. You want to look at this, trust me. Now here, I'm showing you how to view the help page for the neural net and for the network tools. These two packages, right? So basically, remember that the neural, this package you can use for this implementation. You can have multiple hidden layers, and in this specific example, I did only one hidden layer. But to do the multiples, this is what you need to do: is this in your input parameter? Oops, not sure why. Your input parameter here is going to be the, so here it's a list, right? So if I want to have two hidden layers, the first one 8 nodes and the second one 2 perhaps, I have to do it like this, right? This is what I do, and then I just run this. Let me call it NN2, right? So I think in your exercise you're asked to try different combinations of the input parameters. So here what it means is that probably you want to choose a different number of the nodes in a hidden layer, right? So that's one option. And you could try to play with the threshold and the number of steps and so on. So you have different options to check, right? So basically, and if I do this, if I do plot NN2, you will see that I now have two hidden layers, right? I have two hidden layers. Then you have to look at the, oh sure, yes. So you have to look at this here. See this? This is the first layer, second layer, and see those two hidden layers. So here are my inputs. Now I have weights here, weights there, and weights here. And I have to look at the bias. But we cannot see the variable importance. Yes, you can. Yes, you can. Because you cannot use the first one, but you can use the second one. There are two functions. This one. See this? This one. You can use this one. You cannot use Garson, but you can use Alden. You can use that one for the variable importance. Okay? Yes. So let's look at that. This one you can. Right? So everything has its own pros and cons, right? So that's the reason I showed you two. And I'm going to show you the second implementation. Okay, recent files, and this one, NNet, right? NNet is a little bit simpler to use, especially if your data set, if your dependent variable has more than two classes, right? Because there are extra steps involved. If you have the categorical variables with more than two values, and if you have if your dependent variable has more than two classes, there are extra steps. But this is a situation where this package, this implementation will become useful. However, a net package has a limitation. You can have only one hidden layer in this one, but it's an alternative. Now, another plus side is that you don't need to install this package, it's pre-installed, but still you have to load it in memory. You still have to load it in memory and net. And we can still use neural net tools to do more enhanced visualization. So let's run the library command to put this package in the memory. And I'm not going to install this because I already have it installed, but I'm going to run it to put it in memory, but I actually already have it in memory. Now this I can skip because these commands are the same, and what I'm doing here, I'm just setting working directory, and I'm reading the data, and the data pre-processing steps are the same. I still put that in here because if you decide to run this method, right, and when you follow along the recording, then you will be able to run the script from the beginning, right? You don't need to go back to the other code, the other file, to run the data pre-processing, right? Another plus side of this method is that it takes a wildcard here. As you may remember, in a neural net, you have to physically list all your all your dependent variables. You cannot use the dot wildcard. In this method, you can. Right? So let's run this. Basically, other differences is that what you get, another main difference is the output that you get, right? So here, I also want to have, well, let me explain the input parameters. Here, this first part is a formula. This is what I'm predicting if an individual is a smoker. Here, this implementation allows the wildcard. Here, I'm specifying my data, and size is a number of nodes in a hidden layer. And here, I can have just one hidden layer, right? So, I just ran it, and it says that it converged. Now, when I run renames command, it's going to just give me different output components that you can explore. And the next command is a summary, right? So summary is just going to list the weights, but it's really helpful to look at this and to look at the visualization in parallel. So let's do the plot here. Otherwise, it's very difficult to, it could be a little difficult to understand. So, let's close that. And, it's because I have to run my command first, right? I ran it, and now when I do the plot, and PlotNet rather, here, very important, the plot command is not going to work. You have to use PlotNet, right? Here there is no choice. You have to use PlotNet. And now let me zoom in. Well, let's see. You probably will be able to see it like this. Let's read this. Let's see what that means. Here, this one is a weight from B to H1. So it's this one, B1. This is the bias 1 to the hidden layer node 1. So on this line, this tells us what this weight is. This is the input, first input, and the first hidden layer node. So on this line here, this is the weight that I have, and so on, right? You keep going through this, and it tells us what the weights are on each line, right? So to visualize for this package, you have to use the PlotNet. And this information, it tells me that I have 9 nodes in the input layer, 8 nodes in the hidden, and 1 output node, 1 output, right? Now I can also look at some individual components. So this will tell me the number of nodes in each layer. This one will tell me the total number of nodes, which is 9. And this one is a number of incoming connections for each node. So let's run this. So basically, the first 9 in here, right, the first one, they are the input nodes. They have no incoming connections. And then here, why do you think it's 10? Well, it's because we're looking at the one from each we're looking at the one from each input node, right? And from this one right here, from this guy right here, right? So you get, if you look at this here, 10 more, 10 more, 10 more, 10 more, right? And then you got total the 89. So that's basically the number, how the number of weights comes from, right? So here you have no weights coming in here. Then you have 10 weights coming into each hidden layer node, and 10 because you have 9 inputs and 1 from the bias, right? It just basically telling you how many connections you have and explains the breakdown. And then here it gives you the command you ran, and then you've got this one. This is your input variables, basically, right? You can play around with the plot. Here you can do the PlotNet, right? Or you can also change the colors, and you can change, well, there are a lot of stuff you can do. You can also change the sizes, the vertex size, and so on, right? You can run, for this implementation, you can run Garrison and Alden. You can use both methods to determine which predictors are significant, right? So here, apparently, if the building has a ban on the smoke ban is important, apparently. And this is another way to do. Oh well. Once in a while, you might get this error. You just click OK. That's fine. All right. So age, in this case, it has a big negative effect, rather. And then similarly, you can do the classification accuracy for this method. You're going to run the predict NN. This will give you the classification accuracy for your training data, right? And then here, you have to round it, because if you look at it, it's gonna be the numbers. Yeah, so I see a question. How do you go about explaining how NN is working to a business, to non-technical user? Well, non-technical user, I would say it's a set of neurons. It's a set of neurons collected together. It's like our brain, so to speak. And it takes the input, and let's look at it as a black box, so to speak. It takes an input, and based on whatever happens inside, it produces a certain set of output. Or you can think of it as a set of lights, right? Based on the weight on the input, one of the lights comes on, right? And it keeps on going until you get the output. It's a set of neurons, right? You can picture it as a set of neurons. And the ones that get active, the path that actually takes place depends on the weight, and it depends on the values that are put as an input, right? So when I have a new instance, I'm just going to feed it into the network. I'm just going to feed my input values, and the inputs are pushed through the functions and defined at each hidden layer node. And then you get the output, right? You're pushing the input through the network, and you get the variety of functions just get applied, right? It's a difference, one of the big difference between the decision tree, where you're not doing the split starting from the top. You're applying variety of the functions to the input, right? And you have each input variable gets assigned a weight, and the network keeps on training. So you have This approach, and that approach is not using the backpropagation, it's using different methods. Neural net is using backpropagation, so it's using the error to train the network. The weights are readjusted based on the error that is returned, right? It's a backpropagation approach. But here, what I did was I summarized the net approach, right? Unlike the neural net, it's not using the backpropagation. I wrote it down for you here. So this one, it's the implementation. It's a little bit simpler, but it's not. This is a quasi-Newton optimization. So that's a different function that that is implemented, and that's something for you to look into, something for you to research if you choose to use this implementation. There are multiple implementations, but I just chose that one to show you, right? So let me go back. I hope I answered the question. It's just a set of neurons, basically. This is an excellent question, yes. Now let's go back to the RStudio here. And here, I'm going to run predict, and also I have to run it. Yeah. Can you talk a bit more? Which implementation works under which structure? Oh, how would you choose? Okay, let me tell you how I would choose. First of all, if my network has to have two layers, right? If I want to have more than one hidden layer, then I cannot use a net. I cannot do that. I have to use neural net. If my categorical variable has more than one class value, like one example would be the cars dataset that you used before, I would probably use a net, because if I use the neural net implementation, there is an extra work that I need to do. I have to break down my categorical variables into the set, right? So I have to build my matrix first before I can even run my function. There are extra steps, and it's really more complex. So if I was going to assign you the cars data and ask you to run the neural network implementation on cars data, I would have probably started to show you this method, and net, right? And net handles, yes, and net handles easily multi-class. Excellent. It's easier to handle multi-class. Neural network does also. Neural network does also, but there is an extra step that you have to do. There is an extra step that you have to do in there, right? So, and I think I have example prepared. I could show you that too, if you'd like. But here, let's finish this one first. So here I'm doing the predictions, right? And then and then I have to do the confusion matrix, right? Oops, I did something wrong. Something might be wrong here. Anyhow, I did something wrong. It's because, yeah, okay, here it is. So I had to do now let's do the test data. Let's do the test data quickly. Well, I did something wrong in here because I had to do the type is class, right? Okay. So you want to look at the, oh, here, this is much better. Let's look the caret class. This is much better. You want to look at the confusion matrix. But here somewhere I messed it up. Somewhere I messed it up. I have to look at the what I did wrong in here. Okay, I have to look at what I did wrong. Anyway, let's see. Is there a good start on neural network algorithms that works in most cases? Well, this is a good question, Jay. It's hard to say. Well, a net is easier to start. Yes, a net would probably help you to start. Like if it's helpful for the beginner, right? Well, it's probably a good one to get started, especially if I give you something like a cars data, right? Cars data is very, very complex, right? So I have to run this one, and then I have to do this one. But I have to put, see, that's where I missed. I had to put the type equals class, right? Type equals class. right? It's because we are predicting the class. Yeah, so I'll fix it before. Oh, yeah, before giving you this code. I need to. I'll make sure that I'll get it to work. Okay, here it is, and now you predict. Oops. Yes, I'm going to look at this, and I'm going to fix it. Okay, before I give you this file, I'll take a look at this. Okay. So anyhow, the idea is the same. The idea of the confusion matrix is the same as in the other example. Okay. Now let's go ahead, and since you asked, I can show you. What I'm talking about, and it's going to be in my recent files, and I have cars and net. Oh, here it is, neural network cars. Right, this is a cars example. If I'm going to use this as a cars data, do you remember you used the car data earlier, right? So let's read the cars data. Right, this is a cars data. Oops, cars, head, right, and summary. So our cars data, in this case, we have a lot of things going on. We have the categorical variables, right? We have a unique identifier that we have to remove. Then we also have to handle the numeric variables. We have to do the scaling, and we have to handle the categorical variables in here. There is a lot going on, right? This is a hard example. I would not want to start from this hard example until I explained you something easier, right? So if you may remember, the cars data that you used for your other assignments, it has a unique identifier that we have to remove. We have to handle the missing values, and the HP has missing value, right, and the price has missing value. We have to take care of that. Then we have to remove this one, right, the ID. Then our symboling, we know that the symbol in here has a set of predefined values, -2, -1, and it's 0, 1, 2, 3, right? This has a set of predefined values, right? So that's the reason I'm converting it to the factor, right? So this is a factor. Now watch what I have to do. I have to do the scaling, right? And then I have to convert it to the matrix, right? So here, this is what I'm doing. I'm converting it to the matrix first, and then I'm doing the scaling. Watch. Here, I have to do the set seed, right? I have to do the set seed. Now I have to split my data into training and test set. But now, this is a problem. If I just run the neural net command, I'm gonna get the error. And the reason I'm gonna get the error is because I have the categorical variables in my data, right? So the cars data, it has this. It has the categorical variables. And if I just do this, if I just run my neural network method, I'm going to have a problem because this is a factor, right? What I have to do is I have to decompose my factor variable into a set of dummy variables, right? So for instance, this one, number of doors, it has 3 levels. I have to decompose, they're going to be 2 separate variables, and the values are going to be 0 and 1. So the first one is going to track if the car has 4 doors. Another one, if the car has 2 doors, right, it's going to pick 2 dominant values. And it's going to create a variable called number of doors 4, number of doors 2, and so on. So for each value, I'll have to create a separate variable. But if you do this example, I would also recommend removing the matrix because it has too many levels, right? So this is one reason you're not asked to use the card data for this exercise, because this is really complex, but I'm just showing you that it can be done. Yes, it can be done, right? This is what I'm doing here. You have to convert this to a matrix first. You have to convert this to a matrix. If you are going to use the data set with categorical variables, in this case it's hard because you have the categorical dependent and independent variables, right? So if you preview, this is how the matrix is going to look like. See this? That's an intercept, but this one is going to create a dummy variable almost for each value of the make, almost for each value of the body style, and so on, right? So if a given car is a sedan, then body sedan is going to be equal to 1, otherwise it's going to be 0. So this is decomposing. This is a little bit similar to the categorical variables for your logistic regression, but it's similar, but it's different, because the method is not doing it for you. You have to convert this to a matrix first. See, you have to use this conversion first. There is an extra step to do. What's that? Let me see. Did the matrix command decompose the factors? Yes, excellent. The matrix command decompose the factors. Correct. And you have to do that step. If you are using the neural net, you have to do this step. If you're using a net, you don't have to do this step. That's a thing. So if you use a neural net, you have to spell out all of your independent variables. You have to spell them out what you want to use. But if you using a net, you don't, right? It's a different implementation, and it might be easier to understand, because if I started this discussion with this, I would have lost everybody, right? But I have the code written because, well, I just have it written. I was sure somebody was going to ask about it. And then I'm scaling, right? I'm doing the scaling. And same thing for the test data. And now, this is a trick. Because one of my values is -1. The variable name is symbol in -1. This is going to create a problem if you actually feed this into the method. So to rename it, I rename it. I put M1, which stands for -1. I'm just renaming the variable. I'm just playing a little trick in here. And I have to do it in both training and test set. And now I'm going to run my method, but let me show you something. This is a tricky part. I have more than one dependent variable. This is what's happening. It's because my symboling was decomposed also. My symboling was decomposed into a set of dummy variables, right? So that's going to be -1, 0, 1, 2, and 3, right? And here, I just used some of I didn't use all. I picked subsets of the dependent variables. Well, in theory, you're gonna try all, but I just did it for illustration purposes, right? Well, this is just a demo, just to show you that yes, you can do more than one class. Yes, you can have factors. Yes. What's that? Could you repeat repeat what? Oh, this piece here? Okay, this piece here, what's happening is that my variable, my dependent variable, it's a factor here. It has more than one value. The symbol, well, what's happening is that, well, that's a good question. If you should use all the variables, you can play around. That's an excellent question. You can play around because you have to run the method with different input parameters. Running it with different number of variables is is also an option. You can try running it with a subset and see what happens, right? You don't have to. You can play around with a subset and see how it has an impact on the results. Well, I just randomly picked. But here, why do I have more than one dependent variable? It's because my method decomposed. I have the cars, the symbol in its categorical variable, right? But the values are -2, -1, 0, 1, 2, and 3. -2 is the least dominant. But what's happening, there is a little issue is, look at this. If I run this summary, if I run the summary command, and I'm going to do the train data, .data, and I'm going to put the symbol in, right? Take a look at what's going on. Take a look at what's going on. Another challenge is that it's an imbalanced data set. It's an imbalanced data set because look at this. The -2 class, right? On the other hand, if I look at this is a little tricky. That's why you're not using this cars data for this exercise, because this is a little tricky. In my test data, I have 3 cars with risk level -2. In my training data, I don't have any, right? So kind of like -2 is identified as a least dominant class. So I have a dependent variable for each of these, right? 5. So that's a challenge. So I have 5, not 1, but 5 dependent variable. And then for each categorical variable, I have to have more than 1. So for instance, the number of those, you've got how many values? 3, right? So for 3, you have 2 factors. It's going to well, you have to run the command to decompose it. This is an extra step that you have to do, right? So basically, when you do that, you have the extra steps to do. That's basically what I'm showing you here, right? I can give you this example too if you'd like, but here this is harder. Could you please include R file with WebEx? Absolutely, yes. I'm going to give this file to your professor too. And well, and I'll explain. The reason I did it is just to show you that this method can be done when you have the categorical variables, right? This is a little bit tricky because what the output is going to look like, let me show you what it's going to look like. It's like this. Head, my predict. Let me show you what's going to happen here. Oops. This is a little tricky. Watch. It's showing you it's going to show you the probability, right? For each one. And what you have to do is, you have to look at which one has the highest probability. You have to look at which output has the highest probability of happening, right? So you have to run this thing here, right? And then you have to take an index. You have to take an index, and the index of an index of a value with the highest probability is going to be the actual class, right? So that's what it is. You have more than one output, and you want to look at the output with the highest probability, and then again you're going to check this, right? So this is for the training data, and see, the reason you have -2 in here, it's because your data set has classes -2, -1, 0, 1, 2, 3, 4, right? So that's one reason you have a -2 in here. So just for you, something to keep in mind, that if you have the categorical variables, you have to have an extra step in there if you're using the neural network implementation. And yes, this is an extra, and I also have it in a smoking file. I also have it here too. This is an extra visualization class, and you need to have the dev tool installed. And this class allows you changing more on the network appearance, right? So let's see. Now I have to rerun that command. Or actually, I can show you on the cars example. I can show you on the car example how it looks like. You have to, in order to use this advanced one, PlotNet function, you have to install the DevTools and then load it in memory, and then you have to run this script. This is a script located in the GitHub repository. Right? This is fine, this message is fine, and this is more. Well, it's not going to look like more advanced, but, well, it's PlotNet, actually, right? It's PlotNet. PlotNet, that's what it is. Right, but when you put this function here, it just gives you more flexibility. Like, this is what I'm doing in here. Oh, plot.net, that's what it is. Plot.net. It gives you more flexibility because you can change the colors and so on. This one, right here. Well, it might look like it's the same, but it's more. It's more than this. Well, it's okay. You can ignore these warnings. It's just a warning. And what you could do with this is that you can change the, like what I'm doing in here. See this? Well, but now it's gonna do it for the cars example. See this? I'm just changing this. Look what I'm doing. I change the vertex to pink, and then here what I'm saying that if the weight is positive, then I want to show it in red. If the weight is negative, I want to show it in blue, right? That's what it's doing here. And then I can also change this one here, the size of my vertex. Now here, this is an example where I have more than one output node. See this? This is more than one output node. I have 5 output nodes. And the reason is because I'm looking at the categorical variable. My dependent variable is categorical, and it has more than one value, right? So this is a cars example, and the reason you're not assigned this for homework because this is advanced. I call it as an advanced example. So, but I wanted to show you, it was worth showing you, right? And on the other hand, I wrote it, recent files, and it's going to be the cars and net. So let's see. Yes, I think I have it here. Yes, that one. This is a net. But if I'm using a net, I'm just going to skip all of that steps. I don't have to. Well, here, what I'm doing, I'm taking a different approach here. So let's reload the data. This is what I'm doing. I'm doing different approach. I'm running this to load the library in memory. Well, that's okay. That's okay. We can ignore the warnings for right now. Now I'm reading the car's data. And then I'm just doing this. Here, I'm handling the missing values. And I'm going to remove the ID. And I'm going to remove the make. Right? Now, here, what I'm doing is I want to change the last variable because it's actually a factor. Now here I'm going to scale all of the variables that are numeric. See this? I'm going to scale all my numeric variables. Now I'm going to set the seed value, and I'm going to split the data into a training and test set. Now here it is. Take a look at what I'm doing. This is much easier. I don't have to do any decomposition. This is going to take care of it for me. See this? I put my symbol in, and I put just that. That's it. I just let it run. And this is it. I'm done. That's it. I mean, I got a warning, but, well, it doesn't matter. Well, the warning, I'll tell you why I got a warning. Well, it's because I have a class -2, but remember -2 didn't appear in the training data. That's what it means. It's because the variable is skewed, right? The variable is skewed. I had other options. I could remove. There are a few instances. There are only 3 rows with -2. I could remove them, or if I had several values, for instance, suppose that I have -3 and I have only 5 cars with -3, 3 cars with -2, and 4 cars with -4, just an example. I could combine those into a single category and call them other. That's another way to handle it, right? So here I can run my summary feed. Well, I call it feed here, but it's the same as NN. And then I can do this. I can do the plot, right? Well, this is similar, but I'm just using different package. See this? Yeah. So I'm going to do a little bit of editing, add some comments, and then I'm gonna let you have this. I'm gonna let you have this code, right? So here it is. Now I'm gonna do this one. This should work. So this is what I'm missing in there. I have to look. I'm missing the class. See, this is on the test data, and I have to say type class, right? And this is a confusion matrix here, right? And you want to look at this diagonal right here. See this 3, 3, 2, 2, and then you look at 1, 1, 0, 0, -1, -1. But you want, I'm sorry, 0, 0, -1, -1. Well, you can ignore this one, -2. Well, the problem here is that you don't have the -2 in the training data, so that's how it looks like. And you got a warning about it, so well, it's not a big deal. But, I mean, just notice that I don't have to do anything here much, right? I don't have to do this decomposition, which could be very, very difficult. Yeah, the answer is, can you use CarNet? Caret, yes, exactly, you can use caret. Absolutely. Well, I did not put it in here, but I could just go in and the copy and paste. Yes, you may use caret package, yes. So I guess what I'll do is I'm going to do this one. I can do the copy paste from that file into this file. I'll do that, right? While I'll be waiting to receive the copy of the recording, right? I will do this. I'll copy and paste the code for this caret package, right? It's in here, right? I'll do that. Absolutely, you may use this. And I'm going to clean this up a little bit. And this here. The reason I did not put the comments in there right away because I was not really sure how quickly you guys will be able to follow, and if you have time for me to show you the more advanced example, because first I usually try to make sure that you understand the easy example before I proceed to something hard like this. This is a little bit advanced, right? And instead of smoker, we have what? Symbol in, right? Symbol in. Yeah, there we go. There we go. And I can run this thing here. Oh, okay. It's because I have to do this one first. I did not run. It's because I did not run this code here. I have to run this first, right? I have to run this one first. I have to copy this to the NNet, right? This. It will work. It's because I have to run the rest of the code first. Here it is. Oh, it's in here, isn't it? Yes. Oh, it's smoking. I have to put it in here. Cars. I have to put it in cars neural net, and I have to put it in cars and net, right? This is cars neural net, and this is cars and net. Yep. I have to put it here, right here, right? And this is This is correct, and this is correct. Predictions. Predictions. This is plural. I have to make sure that my spelling matches, right? Right? This, this, and this. Oops. Well, I'll have to look into it. But basically, yes, you have to. Oh, it's because I use the train data here. Uh-oh, my bad. It's because I'm using the train data. So I have to use the train data in here, right? Oops. Well, yeah. I have to look at it. I have to look at it really. Okay, so predictions here, this is test data, right? And I have to use the test data in here too, then. Yeah, I have to use the test data. Okay, but yes, what I'll do is I'm going to fix this one, and I'll give you the copy of the fixed code, alright? I'm going to incorporate it in here. Oh, actually, take a look, you got this. But the reason it's actually throwing this error, it's because of the -2 class. See this? So the answer is yes or no. Yes and no. Alex, the answer is yes and no. In general, you can use the confusion matrix package, right? You can use it when your dependent variable has more than one value, right? You can, but the problem is that here you have the class -2 in the test data that is not in the training data, so it's a little bit complicated. It's a little complicated here, so trust me. So yes, and take a look at it. It's a little bit differently. It actually produced the results, but it produced the warnings. And also, the results are slightly different, right? Well, you can use, but the result is going to look differently. And you're going to get a warning. Well, you may ignore the warning for this purpose, but... Oh yeah, take a look at this. -2, right? And the reason you don't have anything in the diagonal is because you don't have any data rows with -2. Symbol in -2 is not present in the training data. So that's what it did here. And then you have a statistics for each variable, separate one. You have a statistics for each because it's decomposed. Does it still produce accurate metrics? Yes, it does. Yes, we can still calculate the classification accuracy. Yes. But, I mean, it should still work. And I believe the classification accuracy was somewhere in the... Oh. Excellent question. That's an excellent question. That's an excellent question. The accuracy is low. Excellent question. Yeah, that's an excellent question. Well, it has to do with other data pre-processing that we would have to do, but my general reason for showing this was that it's possible to do something more complex like this. So if it's something more complex like this, and if you're strapped for time, and if you're a beginner, then you probably want to use NNet. This is really complex, so trust me, that's a reason it's not put in the exercise, right? It's not the starting point. So when I started, we went with the smoking data, where everything is nice and simple, right? There are no factor variables with multiple classes. You don't need to worry about the decomposition, okay? So, but for you, keep in mind that there is more than one implementation. And there are even more. Well, because sometimes, you know, the developers, they run their own packages. Here, we are using the packages, but when you get really comfortable with R, you can write your own packages and your own functions, actually. So, yeah, that's the thing. And what I did here, I just put a little summary of what I showed you today, right? That's a little nice summary. And here, just showing you how to do the predict here. So what I was missing is the test data. You have to put NN, and then you have to put the test data. That's the reason I was getting a little error, but I thought I had it, but well, okay. I'm going to correct the little typo in there, and I'm going to give you this. I'm gonna give you this code. Okay, you will have a copy of this one. Yeah, I'll make sure that you have a copy. See this? Yes, it's because, well, the reason I'm getting error right now is because I overrode the test variable, test data, and train data. It's because I overrode them, right? So before I was working on the smoking data, then I overrode it with the cars data. So yeah, but I'm gonna give you the code. Definitely, you'll have a copy of all of these files, sure. And the car data is the same car data that you used for your other exercises. And now you know the reason you're not asked to use it for this exercise. Yeah. So, but let's see what questions do we have. Is the homework task, is it clear what needs to be done in there? Yes? I like questions. Yes, and let me take a look. Let me take a look at this. Okay. I have two questions. On using the scale function with neural net, can and should this scale be used when one column of data is much smaller? Yes, excellent, yes. You have to use, definitely, if one column, the values in one column are small and the values in another column is good and big, right? You have to scale because the values in a different scale. You don't want one variable to have a higher impact on the overall outcome. Yes, you do have to scale. If everything is numeric, such as in the cars example, you've got the mileage, you've got the weight, you've got the price, you have to scale. Is it better to scale all? Yep, you have to scale all numeric. The reason I did not scale all of the in the smoking data because those were actually like binaries. They have values 0 and 1. The only one that was not was the age, right? So I just did that. What is this? Yeah, you scaled, but the thing is, you want to omit the dependent variable because the dependent variable is a class. So, but your class variable could be a different position in a data set. In my case, in the smoking data set, it's the first one. So you have to really look at which position it is in your file. Yes. So that's a thing. The question is if it's a final. Well, we do not scale the dependent variable, but we have to scale all this independent. Well, you have to scale. Yes, you have to scale all numeric independent variables. Correct. Yes, you do. So that's a data preprocessing for your homework. You want to remove unique identifier. You want to handle missing values if there are any. You want to do the scaling. But in the cars example, if I was doing it, I would probably remove the module because it's too many factor variables. It's making a model really complex. And trust me, when I tried to visualize it, I could not read it myself. So yes. So let's see if we have more questions. Let's see, because I like questions. They're actually excellent. Yeah, but you see an example where you have more than one output node. Yeah. So it's like this. If the dependent variable has 5 classes, you're gonna have 4 output nodes. Four class values, 3 output nodes. That's how it is basically. Yeah. So you're asked to try the different combinations, different parameters. So you probably want to do the different number of nodes, different number of scaled hidden layers. But remember, neural net allows changing the number of having more than one hidden layer, and net only one. Yes. Is there a command to we can change the factor to numeric? Huh. Well, you cannot explicitly change the factor to numeric, but you have to do this one here. If you're using neural net, right? If it's a factor, you have to do this step. You have to convert it to the matrix, and the matrix will decompose each variable into the set, right? Well, if you do, you remember what you did before when you were working on logistic and linear regression? The method took care of the decomposing the categorical variables for you, right? Here you have to physically do this one. You have to convert this to the matrix. It's just how it is here. So I'm doing it in this example right here. Yes, you have to do that physically. Yeah. Oh, sure, you're the most welcome. Yes, that's an excellent question. Yes, because how can we convert if, well, the idea is you have a discrete, you have a categorical variable. It means that the set of values is predefined. So the car can have 2 doors or 4 doors, but the car cannot have 2.5 doors. So that's not a numeric, right? It's a categorical, but you have a separate variable that identifies if, for instance, if the variable is number of doors 2, it's 1 if the car has 2 doors, and 0 if the car has more than 2 doors, or maybe just 1 door. We have to look at the data specifically, right? But the reason I showed you something complex is just to show you that it's possible to do it, right? It's possible, but the car's example is complex also because the class values are imbalanced. You have a class -2, right? That you have to somehow handle there. Yeah. So you think it will help? I can give you this code. Absolutely. So that's gonna be 4 code files. Yes. I'll email it to instructors. Yeah, but let's see what other questions you may have. Questions? I love questions. They're good. Excellent. But for the homework, you're lucky that you got the easiest one. Well, you have to start with simple, and then we gradually increase the difficulty level. Yeah. Oh, you're the most welcome. You're the most welcome, Alex. So I'm so glad that it really helps you. Yeah. And after this, I'm going to email all of the files, the presentation and the code. Okay? Let's see if we have additional questions. So I'm going to stop sharing the screen for right now. And let's see if we have other questions. I would like you to ask questions, right? And if you'd like, guys, if the guys would like to have another class on clustering, so let the instructor know, and then we will coordinate. Because you also have a clustering in a couple of weeks from now. Yeah. So, any more questions, guys? I love questions. So I'm giving you a chance to type them in, and in the meantime, yes, you're gonna have this slides. I just put a nice summary for you, right? Yeah. So basically, some data pre-processing steps are the same, regardless of the implementation you are going to use, right? So this is, I'm just basically explaining you how to test, right? To do the test set and the training set in here. And I will check to make sure that, yeah. Okay, and how to run the method. And this is a summary command. So basically you want to look at this at the same time as you're looking at the plot. It's much easier to understand this, right? So let's see. We don't have questions, right? Well, if you don't have questions, then I'm going to call it a night, and I would like to thank everybody for attending the session. So, okay. Thank you so much, guys. And everybody have a nice evening. I'm gonna end the recording. Thank you.